Okay, section 10.3. The next conic section that we're going to look at is the parabola. Now we've already studied some parabolas before, back when we were looking at quadratic functions. You may remember quadratic functions. We wrote them out something like f of x is equal to ax squared plus bx plus c, and we talked about how to find the vertex. You could complete the square, or you could use the opposite of b over 2a to find the x value of the vertex, and we determined if it was opening upward or if it was opening downward, and we talked about the axis of symmetry. Well, that's all good and fine, but the pure definition of a parabola is a little bit different than how it was introduced to you back in the quadratic functions. And here's the definition that we're going to use. A parabola is a set of all points in a plane that are equal distance from a fixed line, which we call the directrix, and a fixed point, which we call the focus, and that point, the focus, cannot be on the line, it cannot be on the directrix. So I've got a picture here that I'm trying to show a little bit about how this definition gives us this curve. And as you can see, we have a fixed point and we have a fixed line. The line in pink here, or in red, is the directrix. F there, that's the focus, okay? And we are looking for all points, and I have point P here, the order pair xy, such that the distance from the focus to the point is the same as the distance, the perpendicular distance from the point to the directrix. And that's what I've tried to show you here with the purple line segments and the little notches there. The line that's perpendicular to the directrix that passes through the focus is the axis of symmetry. So for this diagram, the axis of symmetry would be the y-axis, x equals 0. The vertex of the parabola is the point of intersection of the parabola and the axis of symmetry. And I've got it kind of drawn here so it looks like it's at 0, 0 here with my x-axis and my y-axis. The distance between the vertex and the focus, that would be this distance right here, is called the focal length, and we refer to as the absolute value of p, because we don't want necessarily p to be thought of as a negative number here as far as the distance, because the ordered pair is 0p, that could be p less than 0. Okay, you know, we might have something that would be like a mirror image or a reflection in the x-axis of this curve. So to come up with the actual equation, not necessarily looking like this, but the actual equation, what we do is we go to the definition and we say that, hey, if the distance between these points and the directrix and the focus are equal, then that would mean, based on my diagram here, that PF would have to equal PD. Now in this case, I have this length, lowercase letter p here, being this distance. This is your focal length here. Notice that this is not only the distance here, but it's also the distance from the vertex, the perpendicular distance from the vertex to the directrix as well. So this part here is p and this part here is p. So if I use this definition and the distance formula, I find that PF, and again, lowercase letter p, that's supposed to be a lowercase letter p right there, is greater than 0 here with my diagram. And I'm going to have this such that I have the distance from p to f, that would be x minus 0, using the distance formula, plus y minus p, quantity squared here, is equal to pt, that would be this distance here. Now as you can see, since my directrix is a horizontal line, that this guy right here is a distance, a vertical distance here. So all we really need would be to subtract the y values. So I'll write the absolute value of y minus the opposite of p. Now to solve and simplify this expression and make it look more like the equation of a parabola, I would want to square both sides to get rid of the radical. Not only will that get rid of the radical, it'll also get rid of the absolute value bars. So I would have the square root of, this would be x squared, plus this would be y squared minus 2py plus p squared. I went ahead and simplified under the radical. Now I'm going to square that. And then over here this would be the absolute value of y plus p, and I'm going to square that. So if I square both sides here, I get x squared plus y squared minus 2py plus p squared is equal to, now when you square the absolute value, you can drop the absolute value bars and just square this binomial, so that'd be y squared plus 2py plus p squared. And what's really convenient here, as you can probably see, is that some of these terms are going to drop out. I could subtract y squared from both sides. I could subtract p squared from both sides. And so right now, and notice here I have like terms, I just have them on different sides. So if I add 2py to both sides, I get x squared is equal to 4py. And that's the equation that we'll look at. Now you say, well, that doesn't really look like what I'm used to. Well, if I divided both sides by 4p, that probably looks a lot more like the equation of a parabola that has the vertex at 0, 0. And in this case it opens upward because this constant here, this would be the a. And since p is positive, 1 over 4p, since p is positive, 1 over 4p is positive, that means that it would open upward. So that kind of matches up there. But you'll see it written most times written this way. In fact, I have the examples of the different situations that can occur if you're looking at a parabola whose vertex is at the origin, because it's always simplest to start with the vertex at the origin. And you'll notice here, I've got one that opens upward, I've got one that opens downward here, where p is positive, and here p is negative. The axis of symmetry is still the y-axis. Your equation is written in this form here, and your focus is at 0p. Notice here that if p is positive, opens upward, p is negative, opens downward. And then you have the types of parabolas that are not quadratic functions. They open to the right or the left. Clearly, they're going to fail the vertical line test. These are not functions. But again, opening to the right if p is greater than 0. Opening to the left here if p is less than 0. Notice the differences here in that now the axis of symmetry is the x-axis, or y equals 0. And notice it looks like they just switched the x and the y here. And they wrote the equation down, and I also wrote it in that form. But again, p is greater than 0, it opens to the right. P is less than 0, opens to the left, and the focus here is at p 0. Remember, the focus, based on the graph, is going to look like it's in the interior of the parabola. Right? See how it's in the interior? The directrix, of course, in the exterior. This distance is p, this distance is p. They're supposed to be the same here and here, here and here, here and here. Now, with all that stated, let's see if we can actually do an example of a problem. It says, given a parabola defined by x squared equals 4y. Okay, now when I look at x squared equals 4y, I'm thinking it looks a little bit like this form right here. And it says 4 times p times y. Well, that would mean that this is the same as x squared is equal to 4 times 1 times y. Although I doubt if I would write it out that way. But that way I know exactly what the value of p is for this. It says find the focus in the equation of the directrix. Well, the focus is going to be, this is going to open upward. The focus, as you can see here, is going to be 0p. So your focus is going to be 0, 1. If you try to get an idea of what this looks like, something like this. So it's going to be right there, and this distance here, this is p, and it's equal to 1. So this is 0, 1, and this distance here would also be equal to p if this is, hang on a second, I think I just wrote, yeah, I wrote 0, 1. So this would be a distance of 1, this would be a distance of 1, which means that this is at negative 1, and my directrix would be y equals negative 1. Don't just put down negative 1. Write down the equation, because just like with the axis of symmetry, it's an equation, not a number. Write it as the equation of a line. Now, the axis of symmetry and the directrix, for all the parabolas that we're going to be working with, are all going to be either vertical or horizontal. So they're always going to be x equals a number or y equals a number based on the circumstance. But if you can keep track, and this is a lot of new information to keep track of, it'll make these problems go a little bit easier, and then you can find the key values that you need to answer the questions. It just takes a little bit getting used to.